Hi, everyone, and welcome to another edition of NeWBiEs nanoCHATs. My name is Anne Bentley, and I teach inorganic chemistry at Lewis and Clark College in Portland, Oregon. And I'm joining our regular guests, who are Shirley Lynn and Wes Farrell, both at the U.S. Naval Academy, and they're teaching inorganic for the first time each, and in parallel this spring semester. And we've all been enjoying following along. So how did it go this week? What were the big highlights?
So we're coming off of our first exam, and I don't know how much of a highlight that was for the students. I think for some of them, it might have been a bit of a wake-up call. These earlier chapters seem to deal with a fair amount of things they've already seen before when it comes to things like bonding and molecular structure and atomic structure. They've seen it all as freshmen, but we're doing a bit of a deeper dive. And I think there might have been a bit of a false sense of security that it's really no big deal. But on the exam, they were asked some questions that are a little bit more challenging and asking them to go a little bit deeper. And it's clear that some of this still isn't hitting home yet. So I think it was a bit of a wake-up call for them. But I also took this time to reflect as well. And I think I might have treated it a little too softly as well, because I thought they were coming in with a lot of experience with this material. So I think for the next time I do this, I'm going to need to keep that in mind and remember that they're going to be coming in at a much lower level than I think that they are.
Yeah, I was going to say, having taught organic several times in the past, that the Lewis structure part, I really emphasize, and I hope that they have down cold, and that's just not true with this group for a variety of reasons, the pandemic, etc. So I was going to ask Anne if you had thoughts on how to best remediate those kinds of skills that we consider as like foundational, but they don't have. I think another surprise on the exam was we asked a question involving, here's a compound, draw its conjugate base, and there were just a couple of people, but they could not do it. They could not draw the conjugate base given the molecular structure. So some thoughts.
Yeah, well, I think inorganic builds a lot on, in my case, quantum is a prerequisite, but certainly Gen Chem's a prerequisite. And it's almost as if they see organic as a detour. So for them, it's been 2 years or more since they've thought about this, whereas we know that everything is tied together. There are a number of LOs, I feel, on the White Viper site that talk about how to assess their knowledge and maybe give them that wake-up call earlier in the semester. So almost like a first day quiz or a first week quiz, like, do you remember all of this? And then they realize they don't. And so, in terms of remediation, it doesn't necessarily provide the content, but it prompts them to reflect on what they do and don't know, which is a good place. And that could be like worth 0 points, or like, not with a lot of high stakes associated with it. But that's definitely something I've heard a lot of people talk about. And I think I liked what you said, Wes. I think I do that too, where I'm like almost apologizing for the fact that the material is similar to what they've had before. And I try to foreshadow why we care about these things, but also I need to do a better job of saying, and you still have to know it, at a pretty high level. Yeah.
Do you usually get lots of people coming for office hours, like out of your class?
That's still a habit. I mean, by juniors and seniors, they're actually in that habit well. And I used to have a daily problem, and I would get a lot more people at office hours. If they didn't get 100% on the daily problem, they would have to redo it. So there's a lot of people parading through for help. This year and last year, I'm using more of a flipped format, and they're daily watching micro lectures on their own time. So I'm not also assigning a daily problem, but I think it's cut down on office hours a little bit. Yeah. So the exam was 1 day, and you meet 3 days a week. What was happening in the other days?
Yeah, I actually have a 4-day-a-week class because it's a 4-credit class. So yeah, they see me every day, Monday through Thursday. And I was going to say that at the beginning of NeWBiEs, when we were talking to Joanne on the first episode, I said, things are going to happen. We're going to be stressed. Well, one of those moments happened this week for me. We were doing MO theory. We were doing the intuitive symmetry adapted approach. And what I learned was that it's super important to define your axes when you're talking about the molecules, because that ends up driving how you solve the problem. And I was using methane as an example, and thank goodness Chip Nataro has this great Chem Libretext site where he goes through this symmetry-based approach, and he was really careful in there to say and define the axes along the C2, the 3C2 axes of methane when you do this. And I didn't read it carefully enough. So I'm here in class and the students are following along, but they're asking these great questions. Oh, where's the node? Where's this? And it was just kind of a mess, right? And so I ended up confusing them, but then went back to it. And then they asked more questions and then had to go back to it a third time. So maybe it was good that we see each other 4 days a week, because 3 of those days was talking about methane for some amount of time. So that was traumatic.
No one likes that feeling of like, you know, walking off the cliff, taking the students with you, and then the Wile E. Coyote, like, oh, we're in trouble now. Yeah.
Yeah, I had a pretty similar thing also with molecular orbitals, because you have these atomic orbitals and the salks, and they can order the atomic orbitals fine, but then they were just asking how do the salks get ordered in terms of their relative energies, and then when they do form the MOs, how do we know what their relative energies are? And I just never really thought about it, because I kind of intuitively was like, oh, of course this one goes here, this one goes here, like it's no big deal. So I had a very similar moment in thinking of like, how do I explain this? And I wasn't prepared for that. So we were able to come back to it and wrap it up, and I think they understood it. I guess we'll find that out on the next exam, but it was a bit of a scary feeling because I hadn't really given it much thought.
I also find they have a lot of concern about the ordering of the specific MOs, and like the carbon monoxide MO diagrams, one that feels a little confusing. I guess I get around that sometimes by emphasizing, like, I want you to tell me how many of each type are formed and what they could look like. If I told you these two mix, what's it going to look like? But less emphasis on the ordering of energy wise. Yeah. But that's like my way, because I share that anxiety. So. Yeah.
You were saying, Anne, that and Lori actually also mentioned this, the mathematical approach, right, to teaching the salts and the LGOs is also great. And we did this intuitive approach. I actually had one of my really strong students say to me in class this week, they're like, I don't get this intuitive. Can we do the mathematical approach? So it just goes to show, right? You have this diverse set of students, and some of them get the math, right? And they want to do it with the math. And then some of them are like, I don't want to do the math. And
yeah,
you just have to make these choices on how you're going to.
Well, and this inorganic course can be such a different course for everybody based on who's teaching and who's learning. Yeah. So what's in the future coming up? Do you all get a break this semester?
We've got spring break coming up in 2 or 3 weeks.
Because 3?
I should know that.
Good.
Yeah, I'm looking forward to it too. Yeah, but in the meantime, we're moving on to solids.
Great. Good.
Yeah. And we're going to be using Nicole Crowder's activity, the in-class activity with the ice kits. And I actually never used them myself. And I'm not a materials chemist. So I'd love to hear, Anne, like your thoughts as a material chemist on how best to kind of leverage that activity or other activities that can help the students.
Well, I would say the ice kits for me was part of why I liked inorganic and materials. Like as a sophomore in college, I got to play with them. Tried to buy some new ones recently and I didn't see them available for sale. That's a different topic, but Nicole's LO is great. And I've used it actually, sometimes it falls when I'm traveling for the ACS meeting in March. And I like tell them you must do this while I'm gone and prove that you did it. But one thing I find when they're working with, and what we're talking about, I brought a model, are these little, plastic spheres here that fit on the rods. And it can take them a lot longer than you think to play with these. First of all, they're just so distracted and it's so much fun. So I'll have like a different group build each, like 5 different models, and then move around the class looking at the models that everyone else built, instead of having each group build all 5, whatever the number is. And then your key takeaways are, could you draw the layer diagram based on this unit cell? I find students get pretty confused about the fractions of atoms that are in cells. So I'll try to look up this Chem Ed article from a long time ago, 10 or 15 years ago, that gives you printouts where you can make these great little unit cells that are actually cut through the atoms and show the fractions. So structure is a big part of solids. And then I don't know how much you'll talk about conductivity and electronic structure.
Yeah,
we're going to get into that at the end with semiconductors and then get into superconductors. And that goes really nicely with their lab as well, where they will make a YBCO superconductor and then, cool it down, try to levitate the magnet on it.
Oh, that'll be really fun. Yeah, I've done that lab before. Yeah, and I would think this materials would be very interesting to naval cadets. There's a lot of applications of materials that they would see, I think. Yeah.
That's great. I haven't done the lab part yet, that goes with the course. So I'm looking forward to the opportunity to do that and see the superconductor experiment, because I never got to do one as an undergrad. So.
Oh yeah, yeah. Well, and having the whole lab in parallel is really fun too. So you could do a whole nother NeWBiEs on that if you were teaching the lab. Yeah, well, it's great to check in and see how everything's going with y'all, and we'll look forward to another wrap up next week.
Thanks, Anne, and thanks to everyone for watching. Don't forget that you can chat with us on the Discord if you have any thoughts to add. I mean, share your stories of lessons gone wrong, for instance. Thanks, everyone.